Hello, we are Team 1 and our team is represented by Kevin Garcia, Guillermo Jacobo, Ana Telles, Guillermo Rivera, Monica Cavazos, and me, Camila Gomez. We'll be doing our learning integrity project of mechanics and the environment.
To start with our background, we're going to talk about gravity and who discovered it. Isaac Newton published a comprehensive theory of gravity in 1687. This is the universal force of attraction acting between all matter. He was the first to invent a theory that applied to all objects, large and small, using mathematics that was considered ahead of its time. When an object is falling under the influence of gravity, it is called free fall. 400 years ago, the remarkable observation that all free fall objects fall with the same acceleration was first proposed by Galileo Galilei.
So in freefall, gravity constantly accelerates an object. So this is the name we give to any process where the velocity changes and also increases its velocity. So we can define this as the change in position divided by the time travel. So for measuring the speed of objects in freefall is not easy because they fall so quickly. So there is a way to make measurements of objects in motion under constant acceleration, and it is the inclinate plane.
So yes, as we said, an inclined plane, as my partner said, we especially use it in this experiment that you will see later in the next slide. We use the inclined plane, which in shorter words is simply a ramp or a board that it has an increasing slope. As you can see in the image, we have them in different angles, so the bigger the angle, the bigger the force we want to apply. A resisting force that we can normally see anywhere is friction. In this, we have other two frictions, sorry. We have a static, which is between two or more solid objects, and, and they are moving relative to each other. And we have kinetic force, that friction that acts between moving surfaces.
So now we will see the experimental procedure made by our teammates Kevin Sotelo, Guillermo Jacobo, and Guillermo Rivera.
So as we saw in the background, gravity was discovered by Isaac Newton, but Galileo determined that it has an acceleration of 9.8 meters to the second power. This causes an increase in velocity, and with this increase, at free fall, gravity gives the biggest push, causing the object to fall to the center of the Earth. And this is how gravity affects the velocity of an object in free fall.
The acceleration of any object under the influence of gravity is called acceleration of gravity, since all objects are dragged in the direction of the center of the Earth. It is denoted as the symbol g. And still on Earth there are variants in the value due to the altitude, latitude, and local geological structure of the region. As we already said, the objects in free fall have an acceleration of 9.8 meters per second. This can also be expressed as a negative acceleration in calculations, directly to the downward direction of gravity.
And the second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased.